Hello and welcome to the next episode of the Introduction to Cybersecurity here at the Prof and the Geek YouTube channel. Today my topic will be around the infrastructures and the data. And in a very unusual way, I have borrowed two slideshows from two of the partners of the Ludovica University of Public Service, because my plan is not just to give you an overview on the security questions of data and infrastructure, but my plan is also just to introduce that what else can you get from the Ludovic University of Public Service at Budapest besides this master program that I'm teaching now online. So today I will have two slideshows, as I mentioned, one from the ENISA, from the European Agency on Cybersecurity, because it is not well known, I think, by the most of the people, that if you are working in the public service, if you're working for the military, law enforcement, diplomacy, or just in general for the public, you can attend some courses which are organized by the European Security and Defense College, ESDC, which is run by the European Union. And the goal for this European Cybersecurity Defense College is to give as much knowledge for the public servants as possible, including cybersecurity. So there are a lot of cybersecurity related courses which are available for those at the ESDC website, including those which are held by the Ludwig University of Public Service together with ENISA, which are around the information security management and incident management. So the first part of my slides are borrowed from these presentations. The second part is borrowed from the EC Council's Network Security Essentials course, which is, I think, also worth to mention here, because we at the Ludwig University of Public Service, Budapest, Hungary, we are partnering with EC Council. We are one of the academic partners of EC Council, and our students can reach on a very fair price those courses which are available at the EC Council course catalog. So our university's master program in cybersecurity is built up in mind to give a very fundamental, basic and strong knowledge for those who want to get the EC Council certifications, like the well-known Certified Ethical Hacker, but this is not just the only one. There are various different courses and various different certifications available at the EC Council course, including those essential courses which are part of our academic curricula, which can be used freely by the academic partners of EC Council, including us. And we chose two of them, one which deals with the questions of ethical hacking, and the other one which deals with the network essentials. So I will use some of my slides which are coming from the network essentials, network security essentials of the EC Council. And then you will see that what kind of knowledge can be covered with these essential courses. So I really recommend to check the course catalog of EC Council. And if you're our students and if you are willing to get those certifications, please get contacted with me, and I can let you know that how can you subscribe to those courses. Again, very fair price can be available for the students, because the EC Council is really willing to support the fresh cybersecurity experts or the future cybersecurity experts to get as much certifications as possible, because that can help a lot to get a new job and to write it in your CV and let your future employer know that what kind of knowledge do you hold. So that is the background. That is why you won't see the traditional courses or traditional background in my presentation. And by the way, just let you know that I got the permission to online stream these presentations from the organizations. So let's start the presentation, and let's start with the first one, with the Information Security Management course, which is held on a yearly basis under the ESDC umbrella together with my university and with NISA. So if you are working for the public and you're interested in such courses, which is usually a 4 days long course at Budapest, usually held in the autumn season, fall season. But if you are willing to participate and be our guests at Budapest freely, because that's a free course for everyone in the public, please just check the ESDC website, get contacted with your national contact point towards the ESDC, and come to our courses when I'm also used to teach. And this topic is usually starting with just an overview that what is the actual design methodology of information security and what was the starting point of this design methodology, design principle. Because in the past, we used to have a traditional security model to build up our defense, our information security defense, which was based on or created around the so-called perimeter. Because back in the old days, we had a perimeter. All of our data, which is the source of the information, and the information security should protect the information through data, through the protection of data which is stored and which is managed on the infrastructure. So originally both the infrastructure and the data were inside the organization, were inside the perimeter, and that perimeter could be protected with a firewall. So in the traditional network model, it is used to say that the security measures should be designed, should be implemented on the perimeter. No matter what is outside the organization, no matter what is inside the organization, if the perimeter is strong enough, no one will ever penetrate into the organization, into the internal network, and no one will ever hurt our data and our infrastructure. What is the problem? It is called, back in the old days when I learned cybersecurity, it is called then the M&M security. The M&Ms, which is, strong at the outside, but very mild at the internal. M&Ms like the chocolate, I mean. So the original and traditional information security was like this chocolate. If you can somehow penetrate through the perimeter, you can get to the mild internal network and you can easily get whatever inside the internal network. And the threats inside the perimeter go unnoticed, so it was very difficult to identify if any such hacks, any such penetrations could have happened. Trust but verify. That was the motto of the old design methodology, which cannot be sustained anymore. It is very old, it is very problematic, and we have to find out something new. And this is called zero trust. It is a totally different design methodology, design principle, which states that unfortunately we cannot trust in anyone. Cannot trust in anyone because there are slight changes in the last 15 years. One change is that the data is not inside the perimeter anymore. Our data can be anywhere at the internet. Our data can be in the cloud. Our data can be on the mobile devices of our users, of our employees, for example. The data can be, for example, in the model of a large language model of the artificial intelligence. The data can be anywhere. Therefore, we have to assume that the data is outside from the organization. Moreover, the infrastructure itself is also outside of our organizations because, as I mentioned, the cloud servers are used to be somewhere else. The cloud is used to code someone else's computers. And, our colleagues are currently using their own computers or their own mobile devices. Therefore, the infrastructure elements are also outside of our perimeter. So, the zero trust model, which is, I wouldn't say new because it was first published in the mid-2000s, but it's getting very popular after an executive order in the United States signed by President Biden in 2021 following a ransomware attack against an American critical infrastructure. It has some different approaches on the security design, what in the yesterday's models we could see before. So one of the principles is that the resources are accessed in a secure manner regardless of location. It doesn't matter what is the location, the data, wherever it is, it should be accessed securely. Access control on a need-to-know basis. What does it mean? It means that no user should always access any data. This kind of access should follow the need-to-know basis. What is needed for a transaction, what is needed for a job, it is the only data that can be accessed by a user exactly during that time when this kind of access is needed. Verify and never trust insiders. What does it mean? It means that, for example, a lot of user credentials, user access, username and networks are leaked on the internet. So if you just go to the haveibeenpwned.com website, and it's which one is the best known source of the leaked data, you can find there, I don't know, 12, 13 billion already leaked credentials. So the credentials of the insiders, of the authenticated users cannot be trusted anymore. So those who seemingly are users, maybe an intruders, and on the other hand, the insiders, those who are authenticated towards our network, our infrastructures, cannot be trusted because, well, too many people have too many access for too many data, so they might be also can go rogue. Inspect and log all traffic. Accountability. We have the resources to store the most security data as possible, and we have the machine learning that can highlight that what transactions are seemingly abnormal. So collect as much data as possible and support the accountability. And the network security design from the inside out, which is called in another way microsegmentation. And it means that we have to set up the network to the most elemental, most tiny elements as possible, and start the network design from the basic element, like from the computer. Because in case of a ransomware, for example, if the ransomware itself cannot jump from one computer to another one, the impact of ransomware can be decreased. So in a nutshell, these are the major principles of zero trust. I might have another presentation on the zero trust later on the details, but I want to tell you the basics, the basic principle of zero trust with verify but do not trust. We should never trust in the insiders. We should never trust on the devices which are on our internal networks. We should always have a control around both the users and the devices and the data and the applications and so on, because with that kind of control we can reduce both the possibility and the impact of any malicious activities in our network. So the past infrastructure was quite easy, I would say. So we had the perimeter and everything was in premise. It was the internet that was outside from our organization, and we had the applications, the storage and the internal users on our LAN, local area network, and we had the firewall, we had the intrusion detection, we had the content filtering proxy, we had the antivirus protection, and we had the URL filter. We even had a subnet for those servers that were accessible from the internet, like the web server, the mail server, but it was quite easy. It was something that could be managed quite easily, because if we had a strong perimeter defense, we could manage somehow the security of this one. But now that is not true anymore, because we have to count with those problems with cloud. We have cloud storage, we have mobile devices, we have applications, we have internal users, we have storages, and we have a much wider and more complex information security environment with next generation firewalls, with data loss prevention, with cloud access, with VPN gateways, with intrusion detection, with content filtering, with content filtering proxy, with anti-malware protection. So a lot of new cybersecurity products and solutions have arrived to this environment. So the infrastructure itself is much more complex, and it needs to be, it has evaluated. So the zero trust model is something that we should follow nowadays. The zero trust model, which has a basis also back in the old days to the defense in depth model. The defense in depth model says that the controls are placed throughout the organization, covering all its information technology assets. We have to think in the security in a more complex way than just setting up some firewalls. And this defense in depth principle consists a lot of preventive, detective, and corrective measures, a lot of administrative, logical, and physical countermeasures, and it creates a complex environment for the company, not letting the intruders to get easily the data. Because what is in the core of this defense in depth model? The data. The data, what we should protect, because the data is the source of the information, and as the information is the result of the data processing, therefore, if we cannot protect the data, we cannot protect the information. The data, what is built in or what is used or managed through an application, the application which is running on a workstation, the workstation which is connected to an internal network, the internal network which is connected to the internet through a perimeter security, which is in general the logical security is protected by physical security, what is operated throughout procedures, policies, and awareness. So in a nutshell, in total, we have to follow this defense in depth strategy because it's like the onion. So everything is connected to everything, and at the end of the day, the data can be protected through the security mechanisms of all the other layers of this onion. So it is if we want to protect the data, we have to implement 2 or more layers to protect an asset. Like, for example, if we are using the data inside an application, we can have some data related countermeasures, like, for example, encryption. But we also need to have, for example, an application level protection, like authentication, which should also accompanied by an operating system level protection, which should also supported by a workstation level protection. So in general, this kind of a layered approach will help us to protect the data. Just a few examples here. So if we have, for example, firewalls, it is a good advice to choose 2 firewalls from different vendors for perimeter protection, because if something, if one of the firewall has some kind of a vulnerability, we have a chance that the other firewall will provide the protection for that specific vulnerability as well. And as today we have a lot of problems with firewalls, with network, with the network protection. A lot of vulnerabilities are identified in well-known perimeter security. I think it's a good idea. Separate firewall and IDS solutions. Yes, because these are 2 different solutions. Entire protection, each control protects assets in different points. So like antivirus protection can be also divided. There is an option to install antivirus protection to the mail server, and there is an option to install it also to the workstation. And with this separation, we double the chance that one of the solutions will identify the malicious software. Defense in depth effectively reduces the risk associated with the adoption of a single solution due to the security vulnerabilities of a specific vendor, malfunction of a device, fail open status of a standalone solution. So defense in depth is quite useful. Quite useful because at the end of the day, we shouldn't protect the infrastructure, we should protect the information, protecting that through the data. So that is called data-centric security. The data-centric security, which starts with the question, what is our data set? How can we find the data? The data itself should be first discovered. The data discovery is something that should be done at the beginning of the whole information security process, because if you don't know that what should we protect, the protection itself won't be so successful. After the data discovery phase, we need to classify the data. What is data classification? We should tell that the data, what we discovered, is how much, what is the value of the data, keeping in mind the business processes and the information value. Then, how can we tell that what is the data what we are working on, and what is the classification? How can we support it with data intelligence and data analytics? Data intelligence and data analytics is kind of an automated way to identify the data and to say the value of the data. And then, if we identify the data, the data life cycle itself, we can defend it from the access perspective, inspect perspective, the dispose and the kill perspective. That means that from the entire data life cycle, some kind of an information protection should be provided. This is data-centric security. Data-centric security, which means that we constantly keeping in mind the classification of the data, and it lets us to constantly evaluate risks around the data and all the supporting infrastructure and so on. This is one of the basic principles of the zero trust as well. Okay, how can we do that? And and now I'm jumping to another presentation which I borrowed from the EC Council. Thank you very much for letting me use their presentation, because if we want to understand the data security countermeasures, I think that this presentation is the one that collects all the relevant information around this topic. So in this module, I will go through the data security and its importance. I will let you know that which are the different data security technologies what we are using. I will show you some security controls around data encryption, and then we will go through the disk encryption, file encryption, and removable media encryption tools. We will understand the methods and tools for data backup and retention, and we will understand data loss prevention. So and you will see that how useful are used to be the different courses around EC Council. So let's start with the importance of data security and the importance and just what was emphasized by the presentation from the ENISA. It is also emphasized here in this presentation. The data is absolutely the basic of everything. We are living in the era of the data. Everyone is trying to collect as much data as possible, because from a large amount of data we can create good information. So the data is the heart of any organizations, because a data-centric organization will create so much information and will be very, very successful. But what is the problem with the data? The problem is that it's very difficult to find the data, because data is just created every time, everywhere. Sometimes it's invisible. Sometimes we cannot even identify the data what we are using, because, like, for example, I have this smartwatch on my wrist, and it is also creating a data, and I'm not really aware that what kind of data is created by this gadget and what will happen with this data when it is transferred to a cloud-based service. So it's not obvious that what are we doing with the data, but we can be sure that there are some critical data around the organizations which are critical from the business operation perspective. And that kind of critical data is the first that should be protected. For that, we need to identify and classify the data, the business critical data, And this is the first step, which is used to be done when we are creating information security inside the organization. Some examples. So, for example, accounting files, the database or any business-related data, the operation system file purchased with a computer, CD, software, important office documents and spreadsheets, software downloaded from the internet, contact information. Just a few examples that might be vital for the business operations. Just think on the critical business process of the organizations and you will have a view that what kind of data can be called critical from the business operation perspective. It is always the first step in an organization to find the business critical data. And the next step, and that is why we are doing risk assessment, for example, because what is risk assessment? Risk assessment is starting with the asset identification, the information asset identification, which is practically the identification of the business critical data and the classification of the data, is the road for identifying those infrastructures that are holding the data, which will let us for setting up the risk environment, and from the risk environment we can identify the vulnerabilities in our infrastructure that are threatening the data and the information, and with these vulnerabilities we can measure the risks, and based on the risk we can set up the countermeasures. So in general this is the risk assessment process, and for that we need, as in the first step, the data inventory which will let us for the asset identification. So data needed to be protected because the attackers are also going after the data. This is the biggest threat nowadays. Back to the NISA cyber threat landscape 2024, they identified 7 huge threats which we should count on, and the data security related threats are the first one in this report. So the attackers are going after the data. They are willing to get our data, which is not good, and this is why we should protect our data. Because if we lose the data, it will cause some problems in the business and in the reputation as well. What can be a threat? For example, the lost theft of laptops and mobile devices, because the data resides on those mobile elements. Unauthorized data transfer to USB devices. If, for example, an insider rogue attacker is downloading the data to a removable media. Improper sensitive data categorization. That means that unfortunately the data itself is not classified on the right way, and if we lose that because of improper categorization, we also lose the valuable information. Data theft by employees, external parties. In a ransomware attack, the cyber criminals are not just encrypting the data, but also stealing that and willing to sell it on the darknet to get as much money as possible. What can be the effect? Brand damage and reputation loss, competitive advantage loss, loss of customer, market share loss, shareholder value erosion, and fines and civil penalties. Thinking just on the GDPR as an example, if the data theft affects some private data. So the data can be everywhere, and the data should be protected from such threats. And for that, we need to implement data security and data security controls. The data has 3 states in its life cycle. The data generally is at rest. What does it mean? We are storing the data somewhere and not using the data. The data can be also in use. What does it mean? We are doing some kind of a transaction on the data, and this data is now transformed in use to information. And data can be in transit. What does it mean? It means that from the data at rest, we are transmitting the data to a place somewhere else, or we are using the data for creating the information, and we are transmitting this information to a software, for example, when it will be used later on. So these 3 stages of the data at rest, data in use, and data in transit, are the places where we should protect the data. Data in use. It can be so in an application, data in transit when the data is on the network, and data at rest when it is stored on data storage. Some examples. So data at rest, inactive data stored digitally at a physical location. For example, customer bank balance stored in the database. What security controls can be imagined in that situation? For example, data encryption, which is very common. If we are able to provide data encryption, like for example, we are encrypting files, it's a good control. Password protection, or in general, authentication. So when we are authenticating someone to get an access to stored data, that's also security control. Tokenization, which means that we are dividing the data in smaller steps and we are reconstructing the data if it is needed. Data federation is the way when we are setting up the whole data set. Data in use, where for example data is stored in the memory and some applications, some softwares are creating the information on that. Data stored in a random access memory, RAM, for example, can be thinked on this situation. How can we protect the data in that sense? Authentication techniques. For example, only the authenticated users can access the results of the data in use. Tight control on this data's accessibility. So through programming tricks, I would say, we can protect the data in the memory. Full memory encryption, again an operating system level solution to protect the data which is used. Strong identity management, just to provide the right basis for accessing the data. The data in transit, data traversing using some means of communication. This is when we are sending the data, for example, on an email through the network. What can be think here? SSL and TLS, so the network level encryption can be an example for the security controls. Email encryption tools such as PGP or S-MIME, when we are encrypting the email. Firewall controls, which are letting us to check that what kind of data can be sent out or let in to the network. So in each state, we are providing a control, a countermeasures, which can protect the data, not letting to transform the data into information for unsupported, unauthenticated users. On the next slide, we can see some data access controls like authentication and authorization. We've already learned about the AAA principle, authentication, authorization, and accountability. This is very basic towards the data. Data encryption, which means we can provide some encryption on the different stages of the data. Data masking, which means that if, for example, just think on the password, I think that everyone has at least 8 asterisk characters for their passwords. This is when we are masking, not letting to be seen the data for unauthorized persons. Data resilience and data backup. This is when we are doubling the data and we are doing some backups on the data. If something is happening with the primary data source, we can have a backup and we can get back our data from these sources. Data destruction. If we are reaching the end of the data lifecycle, we need to delete the data, but deleting from the operating system perspective is not necessarily means that we are destructing the data. So destroying the data is something when we don't need the data anymore and we want to remove it from the storage in a secure way. And data retention. If we need to be compliant with some rules and regulations, sometimes we need to provide this data retention techniques in order to provide the data for a longer period if it is possible. So how can we encrypt the data. Let's see it. Let's check it. Some data encryption techniques. We have three different phases for data encryption. The most general one is disk encryption. When we are encrypting the disk, everything on the disk, everything goes on the storage is encrypted, including those data which are stored, those data which are in the memory, everything is encrypted. This is usually done in all operating systems, and all operating systems are possible to use the disk encryption. Everything is encrypted except the master boot record, which lets us to boot up the operating systems. And if we have the proper authentication data, and we are writing that we can authenticate ourselves, start the computer, that means that everything is decrypted and we can use the operating system. But if the operating system is already booted up, nothing is encrypted, so with an authentication we can access the data. At the file level encryption, we are encrypting the files. So in that encryption type, not everything is encrypted, but solely those specific files which contains some classified information. And the removable media encryption is quite similar to disk encryption. It means that, for example, the USB pen drives, USB flash drives, portable hard disks are encrypted. So if we just disattach the USB pen drive from the computers, the data itself is becoming encrypted. And if we don't have the authentication data, we cannot decrypt it when we are attaching to another computer. Some examples from the Windows world. If you, for example, just turn on the device encryption on your computer, it through BitLocker, because that is the name in the Windows world of the encryption, encryption solution BitLocker, it can you can turn on the BitLocker, and if you, for example, just replace the hard drive and trying to attach the hard drive to another computer, you won't be able to decrypt it without the proper environment around the BitLocker. There are some open source and freely available encryption, disk encryption tools as well. So VeraCrypt may be the best known for that. It's open source. The source of VeraCrypt is verified by independent reviewers, and it's widely used outside the Windows world or inside the Windows world for those who are not willing to use the BitLocker for full encryption. It can, for example, encrypt a whole volume on the fly, and it can be easily used. But there are other solutions. BitLocker was mentioned, but FileNearCrypt, Sekrite, FileVault are all examples for the full disk encryption. So what else do we have besides the VeraCrypt? We have the file level encryption. So if we want to encrypt, for example, some files on the Windows machine, we have the encrypting file system, and in the Windows, which can provide a file system level encryption. You can see on the screen that how it can be reached from the command line interface. So with the cipher command, for example, we can encrypt a file which can be decrypted later on. But VeraCrypt can also be used for such situation, and the advanced encryption package is also an example for how to encrypt it on a file level. Xcrypt, IDO file encryption, Cryptomator, and Crypto are all examples for that. And I have to mention here a Hungarian startup, which is not a startup anymore, but very well known. It is called Trezorit, which provides file level encryption in the cloud world. Okay. Removable media encryption. This can also be done in the Windows world with BitLocker. With the BitLocker drive encryption is something that can be used to encrypt the USB pen drive. And although the BitLocker is not available in all Windows machines, I think that for those Windows versions which contains the BitLocker drive encryption, this is also a good solution for encrypting every file which we are transmitting to USB pen drive. Some other examples, the IDO USB encryption, the Carcasoft USB security, the Rohos mini drive, the McAfee file and removable media, or the MFG removable media encryption are all examples. And I have to state here that I'm not sure whether, for example, the McAfee file and removable media protection does exist anymore. And this is the one that maybe that should be corrected by our colleagues at the EC Council. So the review of the tools are highly advisable. But at one point there were some tools which were available for USB encryption, like the Gilisoft USB encryption, which is another example. But I think that if you just check the internet, you can find some trusted solutions which can be used for USB pen drive encryption. Okay, move on. The next topic is about backup and retention. Why do we have the backup and the retention? Because we need the data. Sometimes bad things are happening with the data. Sometimes the storage itself have some physical damages. Sometimes we are attacked by a ransomware group. Sometimes the data itself is simply deleted unintentionally, and we need to get back the data. So backup is maybe the most important preventive logical countermeasures around data security. Data backup is when we are duplicating the data. It's good because in the digital world, when we are duplicating something, the quality of the data won't be decreased. The quality of the data will be the same like the original one. So during the backup, we can provide the integrity of the data on the same level like in the original one. So we are using backup because of two purposes. First of all, to reinstate the system to its normal working state after the damage, or to recover the data and information following data loss or corruption. If we have a successful data backup, it means that if anything happens after an incident, we can go back to an optimal way in our data, and we can restart our business operation as soon as possible. So the backup is one of the most essential countermeasures in information security. How can we do that? What should be thing during the design processes? Well, first of all, we need to identify the business critical data. Like in risk assessment, like in all information security processes, we need to understand that what data is critical from our perspective. Next, we have to select the backup media, because there are various different backup medias, and we need to understand that which backup media is the most ideal for us. Selecting a backup technology. Also, there are various different backup technologies, and depending on the resources, depending on the needs, depending on the compliance requirements, different backup technologies can be useful for us, and we have to choose wisely. Selecting the appropriate RAID levels. If we decide to have RAID in our backup solutions, we need to understand that which RAID solution is the ideal for us. Selecting an appropriate backup method. So not just the media, but the backup method is also a decision point for us. Selecting the backup types, choosing the right backup solution, and conducting recovery drill tests are all the essential elements of the data backup strategy. So let's see that what should be decided here. First, choosing the backup media. When we are choosing the backup media, we need to understand the organizational requirements. So what reliability level is awaited from the backup media? What usability level can be used in the current maturity level of our organizations? What speed is required? What kind of cost estimations, cost considerations should be kept in mind? What is the availability of the media that is required? Based on that requirement set, we will be able to find the right level of the right form of the media. Some examples of the backup media. So back in the old days, we had the optical discs, and on these optical discs, we can save easily tens or hundreds of gigabytes, like CD or a DVD or a Blu-ray. It's easy, it's cheap, it's affordable. It's very easy to make the backups on the optical drives. Recording and verifying the backup is, by the way, it's very slow, and we are not really using optical methods anymore. I mean, we have, so I still have an optical drive in my computers, but it's not so common that we need to have the optical backups, because we have much better backup medias. For example, the portable hard drives or the USB flash drives. No limit, it doesn't mean that it has no limit, but we can even save terabytes of data on a portable hard drive, and it's still affordable. Its apps can also be seen. It's more expensive than the DVD backup, of course, and it's less recommended for small backups. And sometimes we have the tape drives. The tape drives, which are widely used in an enterprise environment, but I think no one really uses it in a small and medium enterprise environment, and especially not in a home environment. Meanwhile, they are very good. They can also store a huge amount of data. It is easy to be stored and easy to be transported, and it's a proven way to store the data for a very long time period. But these are expensive solutions. So back to the RAID. What is a RAID? It's an abbreviation for the redundant array of independent disks, and it is used for increase the resilience of the data. This is a method when we are combining a lot of hard drives into a single unit and writing data across several disk drives, and this can increase the fault tolerance of the classical drives. If one drive fails, we will have some other drives, and we can provide a much higher level of availability to the systems. We are placing the data on different RAID disks, and you will see that how we can, for example, by increasing the input and output operations, the speed of the input and output operations, and with that one, the whole system is getting faster. This is also a backup, so it can provide a secondary storage in case something happens with the first level of storage. And there are 6 different levels. We have the RAID 0, the RAID 1, the RAID 3, the RAID 5, the RAID 10, and the RAID 50. Depending on what we are choosing, we can have different kind of benefits. So let's start it. Which are the advantages and the disadvantages of the RAID systems? First of all, the RAID can offer also the so-called hot swapping or hot plugging. So that means that if we need to replace something, we shouldn't stop the whole system. RAID supports this striping, which means that it can improve the read and write performance of the whole system. And it can also increase the integrity of the system by providing parity check, which prevents the system crash or data loss. Disadvantages? Of course, RAID cannot be implemented in all kind of hardware and all kind of software. And in some of the RAID setups, if one drive fails, everything will fail and we will lose everything. RAID cannot protect the data and offer a performance boost for all applications. It's really dependent that the hardware and the software are designed to operate together with the RAID systems. So the RAID storage architecture is like this one. As you can see, we should have a RAID control processor. We should have the interfaces where the drives are attached, and we should have an operating system that supports the RAID operation. So in that sense, we have the RAID controller that manages the physical disk drives. We have the IDE, the SATA or the SCSI interfaces where the hard drives can be connected. We have a multi-port memory controller which provides the memory access to the data, and we have the SD-ROM which is synchronized with the CPU for clock speed. So in general, we need to have an environment that supports the RAID. Okay, so let's check the different RAID levels, starting with the RAID level 0. This is called disk striping. It means that the data itself is divided into two different sets. One half of the data is written to the disk 0. The other half of the disk is written to the RAID 1. Why is it good for us? Because it dramatically improves the input and output load of the data, so it increases the performance of the whole system. What is the problem? We cannot restore the data if something happens with one disk. So if one drive fails, we will lose all the money because half of the data will be impacted because of this disk failure. It requires a minimum of 2 drives. It increases the performance, but it cannot provide data redundancy. So this is disk RAID level 0. What is RAID level 1? This is called disk mirroring. So every bit of the data is copied to another disk, and we will have simultaneously the same data on 2 different disks. It duplicates the data, and therefore if something happens with one disk, we will have a copy, a bit by bit backup on a different data, so the data can be recovered. It also requires a minimum of 2 drives. It is not improving the efficiency of the data, but it can provide the data backup. What is RAID level 3? This is this striping with parity. It means that, as you can see, the data itself is divided into, in that case, 4 different sets. So we have A0, A1, A2, A3 as the 4 sets for subsets of the original data. And we have a so-called parity bit on the 5th drive. So if something happens with the data, if the integrity of the data is affected, with the parity check, with the parity data, we will be able to recover the original data. So the RAID 3 enables data recovery and error correction on a byte level. It needs so many drives, multiple drives. In this example, we needed 5 drives. RAID level 5, this is called block interleave distributed parity. In that case, we have also this striping and we have parity check as well. So A1 is on disk 0, A2 is on disk 1, A parity is on disk 2, meanwhile B1 is on disk 0, B2 is on disk 2, the parity is on disk 1. So it's kind of this distribution of the bytes to different ones. The data is striped at the byte level across multiple drives, and the parity information is distributed among all the member drives. It makes the data writing process very slow, but the parity itself will stay in a good shape. so a good level of error correction can be provided. RAID level 10. RAID level 10 is not 10 but 1 plus 0, so it holds all the good attributes of RAID 1 and RAID 0 because the blocks are striped and mirrored. So in the same time, it will have a combination of these two methods, and with the implementation of 4 drives, we can provide the same fault tolerance like in RAID level 1 and the same mirroring like in RAID level 0, and we will have some mirrored pairs of data, and this the data striping provides the maximum performance in that sense. And as you can see, A1 is also on disk 0 and disk 1, meanwhile A2 is on disk 2 and disk 3. So that is how we are dividing the data between the different levels. And last but not least, we have the RAID level 50, which is again not 50 but 5 plus 0. So we can combine the RAID 0 striping and the distributed parity of risk of RAID 5, which can be more fault tolerant than the RAID 5 but uses twice the parity overhead. But it consists minimum of 6 drives for the setup, so it requires a lot of drives. It has the highest level of redundancy and performance, so sometimes it is chosen because of that reasons. But most of the time, the RAID is not really sufficient because RAIDs should be implemented in a computer. What happens if we don't want to store the data in a computer, but we want to store the data on an external backup on the network? For that, we are using the storage area network. The storage area network, which requires, first of all, a high-speed network when the data from the computer can go directly to the network-attached storage. No, this is something else. This is the NAS. This is something else. In case of a storage area network, we can transfer the data fastly towards the servers that are storing the data, and any kind of storage devices like the disk arrays, tape servers can be accessed through the network with a very high speed I/O input and output interconnect. So for example, through fiber channel, SAS, or through the Ethernet. The SANs are used by large enterprises, by those who needs to have large backup environment and who have the money to provide that kind of backup solutions. So the SAN is usually used for data archival, backup, restore, transfer, retrieval, migration, and mirroring from one storage device to another storage, and it can be used for a large amount of data. The communication needs some physical connections, so it's not a wireless connection. It's really something that requires high speed, usually wired networks. Okay. And which are the advantages of storage area network? Storage consolidation, so we will have a unified storage at the end of the day. Ease of data sharing, because everyone can, of course, have the authorization to access the data, can access the data. Improved backup and recovery, so most advanced backup strategies can be chosen. Reliable and secure centralized data storage, high performance and low latency, LAN-free and server-free data movement, LAN-free and server-free backup, highly available server clustering, data integrity, and disaster tolerance. So SAN can be used by larger enterprises for data backup. And I've already mentioned the NAS, the network attached storage, which can also be used in homes as well, because the NAS is a file-based storage and it needs nothing else, just one device with a storage that can be connected to the local area network. And with the NAS, it is quite easy to set up, for example, the backup solutions of a home or a small or medium enterprise. I wouldn't say it's cheap, but it's a way much more cheaper than either a tape or storage area network, and it's quite accessible even for those who are not the experts in the backup and in the network at the storage area. So it can be both in a shop, it can be downloaded as an open source software, but what is the advantage is that the different operating systems can use the network at a storage as a backup because it's quite compatible with all the operating systems. These solutions are usually plug and play, so you just buy it, just boot it, attached to the network, and it can be used without any further administration or with minimal administration, because it's really easy to use in general. Disadvantages: applications that use most of the data transfer bandwidth will significantly reduce network performance, but I think if you have a gigabit Ethernet in your home, that shouldn't be a problem. And data transfer is inefficient as it uses TCP/IP instead of specialized data transfer. Yes, for the sake of compatibility, we are using well-known protocols for data transmission. Which is the right decision for the backup method? Well, it really depends on the organizations. It really depends on that how much money are we willing to pay for the backup, and our capability in general to save our data. A hot backup, an online backup, can be something that is constantly replicating the data to another place. So, for example, when we are running an application, a database, or a system in general, we are constantly backing up the data so we can switch over, for example, on the different media sources if it is necessary. The disadvantage is, of course, this is very expensive. In case of a cold backup, in case of an offline backup, the backup is done not synchronously but asynchronously when it is backup time. So, for example, once in a day. And during this backup, we can, for example, make a full backup or an incremental backup when we are replicating the whole data or just a subset of the data, which is good because it's least expensive, but it needs time to get back to a specific point in the backup. And the warm backup nearline, it's a combination of both the hot and the cold backup. It's less expensive than the hot backup, but switching still needs sometimes, of course, less time than in case of the cold backup, but it's still less accessible than the hot backups. Okay. Choosing the backup location. It is used to be said that the backup should be placed in different places. When we have an on-site data backup, it's good because if something is happening, we have the data on the on-site, so we can get back our data fastly. But if something happens with the on-site, so for example, it just burns down, we won't have the data in anywhere else, so we cannot replicate it. So we have to balance between that question, whether should we have to be prepared for any disasters on the on-site, or that shouldn't be a problem, it's not a huge risk, and we can accept this one. So the advantage of the on-site data backup is that it can be easily accessed and restored, it's less expensive, but the data loss risk is, of course, much bigger than in case of, for example, the off-site data backup. When we are storing the data somewhere else, and if something happens with our own site, with our primary site, we can get back our data from these remote locations, because usually the offsite backups have the sufficient physical security, but the problem is that we have to solve somehow the regular data backup. Cloud data backup, I think this is the most common one, because those who are using Google Drive, for example, you are storing the data in the cloud invisibly, which is good because it's quite easy. Everything is supporting that kind of solution. And the advantage is that the data can be encrypted and free from physical security threats. The data can be accessed from everywhere, but of course we don't have any direct control on the data, and of course it needs more time to back up the data, keeping in mind that it needs some bandwidth to back up our data. Okay, what kind of data do we have? In general, there are three different types of backup. The first one is called the full backup or normal data backup. In that case, everything is backed up. All the data is copied to the backup media. The next type of the backup is called differential data backup. In that case, all data that has been changed since the last full backup is copied to the backup media. And we also have the incremental data backup. In that case, only files that have been changed or created after the last backup are copied to the backup media. On the screen, you can see that what is the major difference between the full backup and the differential backup, and the full backup and the incremental backup. So in case of the differential data, we are backing up on Monday just those data that was changed since Sunday. On Tuesday, we are backing up everything that has been changed from Sunday, so even Monday and Tuesday is backed up. And on Wednesday, we also have the backup from Monday and Tuesday as well. And of course, everything that has been changed on Wednesday as well. In case of the full backup, we have the Monday data. We have the Tuesday data, and we have the Wednesday data. So if we want to go back, get back our data after the full backup, we first have to go use the Monday backup, and then have the Tuesday backup, and then the Wednesday backup. So it takes much more time, but of course it's a very much more efficient than in case of the differential backup. So, advantages and disadvantages. The advantages of full backup is the restoration is quite fast. Of course, because we have all the data. Disadvantages, the backup, meanwhile, very slow, because we have to back up all the data. And of course, it needs high storage. In case of differential backup, it's much more faster than a full backup. The restoration is faster than the incremental backup, and the reduced amount of storage than a full backup. But restoring data is slower than a full backup and slower than an incremental backup. And the advantage of the incremental backup is this is the fastest method. It has the least amount of storage space among other backup types, but the slowest restore speed among other backup types. So it is used to be said that we have to find a good mixture of all these backup types. We need a full backup, like every week, on every Sunday, for example, and we can choose which one is the more efficient for us on the weekdays, differential backup or the incremental backup. How can we back up our tools? Of course, we have a built-in backup tools in Windows, like we have a backup tools in all the other operating systems. I wouldn't say it's easy to set up, and these are the most effective ways for backing up, but we still have one, and we still use it if we have backup storage. To be honest, I think that it's very rare that we have a good backup solution. I recommend the cloud-based backup if it is possible. For our critical ways, keeping in mind that I'm talking in a private person's perspective. But there are some other solutions like the Genie Backup Manager Pro, the PullGuard Backup, the NTI Backup Now, Easy, the Power, Go 13, or the Backup for All. I don't know whether these solutions are still existing, but we have these solutions here. Retention. Sometimes the data should be kept for a while. Why? Because there might be some compliance requirements, for example, that says that a specific type of data should be kept for years. The data backup retention policy is the basic administrative source for us that is telling that what kind of data should be kept and for how much time. And the data retention policy should also be written, keeping in mind with that one. Data retention is the process of storing and maintaining important information for meeting compliance and business data archival requirements. This is the definition. And the data retention policy is a set of rules for preserving and maintaining data for operational or regulatory compliance requirements. The policy defines the required retention periods for different data types and sets the minimum standards for destroying certain information. What can be in the data retention policy? So, for example, for those who are providing digital services, might keep the IP addresses or the login logout information for future investigations. Okay, how can we set up a retention policy? First, we need to have responsible teams for that. We have to understand which are the legal requirements, what the law says about data retention. Then we need to identify and classify the data that should be written in the retention policy. And that based on that source information, we need to write the retention policy and ensure that everyone understands that what retention principles should be kept inside the organization. Some best practices regarding this one. First, we need to create the retention policy based on the legal and the business requirements. We need to have a justification on the policy. We have to start with some minimal requirements and improve the policy based on the new requirements. We have to create the policy as simple as easy, because everyone should understand the principles. We have to create different retention policies for different retention types. In general, the retention is covering the customer, subscriber, and the user information, keeping in mind that the GDPR, the privacy policies should be kept in that sense. And if we have this policy, we have to implement the retention in the software that holds the data, and classify the data and decide whether it should be archived or deleted after the retention period. Some data recovery tools can be seen here, because if we unintentionally deleted the data, such tools can help us to recover the data. As you can see, the ESAS data recovery software can be seen here as an example, but there are other examples for recovering the data. Okay, and as the last part of this presentation, we have the data loss prevention concepts. What is data loss prevention? With data loss prevention or data leak prevention, because for DLP, there are two different abbreviations can be found. So data loss prevention or data leak prevention says that we should have a cybersecurity countermeasure that help us to stop the unintentional or rogue data leaks from our organization. It includes a set of software products and processes that do not allow the users to send confidential corporate data outside the organization, which means that we should somehow classify the data as confidential. So we should have a data inventory and a data classification scheme. And this is the weakest point for a DLP. Because for a good DLP, we should discover the sources of the data leaks. So we have to have an inventory on the software. We have to monitor the sources on the data leakage. We have to protect the organization assets and resources with that solution. We should prevent the accidental disclosure of sensitive information. And we should manage the resources according to the business laws. So setting up the DLP is not as easy as it seems to be, because as the weakest point, we have to identify the sources of the data. And the sources of the data, as I mentioned before, the data can be everywhere. But nowadays, the DLP are widely used, usually because the endpoint protection softwares usually contain some kind of a DLP. This is called endpoint DLP, and it is usually the part of the so-called EDR, endpoint detection and response solutions. And the endpoint DLP helps us to identify the data leaks from the endpoints. I mean, generally from tablets, from laptops, from general PCs, PC-based systems. And of course, it's very difficult to solve it, for example, from mobile phones. What does it monitors? It monitors the reports, the removable devices, sharing applications, and let us to identify if some protected information is going out from the endpoint. The network DLP is also commonly used and commonly implemented solution. It monitors, protects, and reports all data in transit. It's difficult because in so many times the in transit means encrypted data, but if the risk analysis itself says that it is possible to implement the network DLP, why not? It is generally installed at the perimeter into the next generation firewalls and GFWs, and it helps us to identify the data that is going out from the organization and let us to be notified if such data is going out which is not on an illegal way. Storage DLP is a solution that monitors and protects data at rest. So if someone is downloading the data, for example, from a file server, from a database, from SharePoint, it helps us to identify that activity. Another example, the Windows information protection, which is an endpoint data loss prevention, but I think it's very, very outdated because now in the case of the Windows, its internal EDR is the one which provides the solution. Some examples, I think most of the solutions are not on the market. So another sign that our colleagues at the EC Council should update that slide deck. But what is much more important, that why do we have the DLP? We have the DLP because we think that DLP can be useful. There are some preliminary requirements for the implementation of the DLP, and for that, the major question before we are starting to implement the DLP, that why are we doing that? What is the main objective of the DLP? For example, identifying the sensitive data for protection, but for that we need to have an idea that what kind of data do we have and what is the classification of the data. If we have this one, of course we can choose the right DLP vendor and choose that kind of DLP products that is compatible with our infrastructure. But we also need to keep in mind that this DLP solution should be operated by someone. So we need to set up the roles and responsibilities in our information security policy who is responsible for the DLP losses. So the DLP itself is quite a controversial product. It can be very, very successful. It can be very, very ineffective. It really depends on how the organization itself can implement it into its live system. So, in a nutshell, that was data security. That was how we are protecting the data, or at least that was the approach what is used by the EC Council for data protection. Of course, a lot of other things can be mentioned around the data and infrastructure protection. I will get back later with another lectures identifying and analyzing this data. Summarizing this module, we highlighted why data is important, and we highlighted how the different data security solutions can support data security inside an organization. We went through the disk encryption, file encryption, and removable media encryption tools. And we also touched the questions of data backup. The data backup and data retention, including, for example, the RAID systems. We also mentioned the DLP solutions. So that was for today. Thank you very much your attention. And I'm just checking the comments on the online stream. So if you have any questions, please let me know what you have here. I see that there are some comments. Yes, cloud backup. I also prefer cloud backup, to be honest, because the cloud is nowadays the cheapest solution for backing up the data, and incremental backup is also a good solution. Use Grafana and Atlas. Do not use replication and cluster. Thank you very much for the advices, and thank you very much for the comments. So that was my presentation for today. If you are interested in any more presentations, any more lectures on the introduction of cybersecurity, we will continue this section. I will let you know through my LinkedIn channel when the next chapter of this introduction to cybersecurity will go live. I will get back to my own slides. Thank you very much for both ENISA and for EC Council for letting me use these slide decks. Again, if you are interested in some more topics from both organizations, if you are a public servant, please join us through the European Security and Defense College to the cybersecurity related courses at the Ludwig University of Public Service in Hungary, Budapest. And if you are interested in the EC Council courses and you are students at the university, just get contacted with me. But I think that if you are outside the university, you can also reach a various different education offerings from EC Council. You can even subscribe to their online courses. You can reach the online laboratories. You can also reach the online e-learning materials, and of course can get an EC Council exams if you are successful. If you are living in Hungary and you are willing to have an exam, you can do your exam at the Ludwig University of Public Service as well. So that's for today. Thank you very much for your attention. If you are watching that online, see you later. If you are reviewing this stream and if you have any questions, just leave a comment and I will answer it. And if you like that stream and you are willing to support me, you can click on the thank you button under my online stream, and you can support the Prof and the Geek channel for providing similar cybersecurity contents in the near future. Thank you. See you later.